In this session, we will try to understand what is UML. We will try to go through the basic definition of UML, and then finally we will try to see that what exactly is UML in real software life. So first thing, just let's make a quick walkthrough of the full form of UML. It is nothing but basically unified modeling language. First, let me make it clear, it is not a programming language, it is a modeling language. So that's very important, because many of the people think that it is probably a language something like C# or Java. No, it's nothing related with programming. It is basically related with modeling. Now, what does a modeling language mean? First, let's try to understand what does a modeling language means. First, let's try to understand what is a model. I think that's more essential. A model is nothing but it's the final representation of a product. So for example, that if you are doing a construction, let's say you are probably building a house or a bridge or something, the civil engineers first make a model, and taking the model, the workers basically finally make an output, which is either your whatever construction process it, whatever construction it is, either a building or a bridge. So in the same way, in software, we can create these models much before coding or execution using unified modeling language. So let me now define it. You can say that it is a language by which a technical architect can communicate to his developer that what exactly he wants, or how should the project proceed, or what should be the roadmap or the technical roadmap of the project execution. In another way, if you want to really define at a very ground level, you can say that it is a way by which one can express, or the technical architect can express, the design of a software architect. One line sentence simple, again we put it, it's a blueprint of your source code. So basically what happens normally in software lifecycle is that you get a requirement. Once you get a requirement, you start making a technical document. Now technical document is where UML will play his part of role. So basically in the technical document, the architect tries to put as much as clarity or define the technical roadmap by which during the execution phase it becomes much easier to achieve the goal. It has in all 9 diagrams which we can use, and all these diagrams in UML have their own perspective of expressing the design of the software architect. For example, if you look at the class diagrams, they basically represent the static structure of the software architect. If you look at the deployment diagrams, they basically show that how the software is going to be installed or deployed across the servers. So basically each of these diagrams define a point of view towards a software architecture. Okay, let's try to understand in actual way that how does this actually happen. I mean to say, if you can make us understand by a simple example, so it would be great. So what I will do is that I've taken a simple screen which you can see in your video. This is a simple voucher entry screen. So the user who comes in, when he starts the UI, the first thing happens is that the debit account numbers and the credit account numbers get loaded in a combo box. So they get flourished. Then the user comes in, he enters the voucher number, the date, he selects the debit account number, he selects what kind of credit account number, puts in whatever cash description or voucher description we are discussing about, puts in the amount and adds a voucher. Once he adds a voucher, an entry goes inside in the grid. Again he takes a second voucher number, puts in the date, puts in this, puts in all the detail, again adds voucher, again the entry goes in the voucher grid. In case he feels that there is something wrong, he can use the cancel voucher and cancel the transaction. Finally, when everything is right, he clicks on submit voucher, which leads to addition in the database. Now this is a pretty complicated screen, okay, and this is what you've got in the requirement. This is what the customer wants, but this can be made easier if we make one UML diagram, and that UML diagram can give us the way to construct this in actual execution. So now what we will do is that in the next diagram, in the next slide I'm going to show you a diagram where basically we will try to put a technical roadmap using one of the UML diagrams called as a sequence diagram to see that how we can execute this particular screen, or how we can technically achieve this particular screen. What are the various components in the screen? What are the way they will interact? So here's what it is. So basically, here's your accountant, the user, who will actually load the UI. So this is a UI, that is your voucher entry screen. Then I have made certain components like vouchers, account masters, and the data access layer component. So basically what happens when the user first starts the screen, the UI is loaded, and if you remember, there were two combo boxes which had account codes to be filled. So basically the UI queries the account master component and says, please give me the codes, account codes. The account master basically sends a message to the data access layer, says, can you please go to SQL Server or Oracle, whatever database you have in your system, and get me the code. He returns the values to the account master. Account master returns the values to the UI, and UI basically displays to the user. The first sequence is completed. In the second sequence, the accountant enters all the vouchers. He adds a voucher button. Okay, as soon as he adds the voucher button, the UI sends this instruction to the voucher component. So if you look at it at the top, we have basically a voucher component, account master, a data access layer, a UI. The voucher component adds this voucher to his collection, or whatever it is, a temporary memory resident, whatever he has in his in-memory representation of the voucher object, and he says, do he want to add more vouchers? If yes, then again this cycle continues. If no, then he goes to the click submit. Okay, and then the click submit calls all the vouchers in a loop and adds to the database. Now what has happened with this diagram? This diagram has given me some detailed technical roadmap by which a developer can actually code, in the sense, probably he will be making classes, voucher class, accounts master class, a data access class. Probably he'll be making a load UI methods. He'll be having probably a add method in the vouchers. So in this way, by this UML diagram, we have defined a technical roadmap for the programmers. So this is what basically is UML all about. UML is, you can say, as I said, it's a blueprint of your code. Okay, and the best part about UML is that you can define a UML, and later it's either Java, or it's either C#, or either it is C++. It doesn't matter, because classes are classes in all these languages, components are components in these languages. So the object-oriented concepts all basically remain same. So probably you can push ahead, or you can say that you can design your technical documentation irrespective of what language is going to come later on. So we conclude. I hope that we have understood UML, and I conclude this video over here. Just one point to remember is that we have 9 diagrams in UML. It doesn't mean that we need to use all the 9 diagrams. For example, in this diagram I have used this sequence diagram to show the simplicity of that UI, but it's possible that you don't need this complicated diagram. Probably you will need some other diagrams like the state diagram, or probably you will just need a class diagram, or you will just need probably a component diagram to define, because if your system is very simple, then you don't need all the diagrams. So one essential important thing to remember is that use those diagrams which your project needs. See the context of your project. If your project is very simple, don't try to put all the 9 diagrams. But if your project is very probably having a lot of activities, a lot of sequences, a lot of states, a lot of components, a lot of interaction between them, then at that moment you need to decide what is my problem context, or what is the way of representing this into the final solution, and then decide a UML diagram. So what we will do is, in the further coming videos, we will try to understand all these 9 diagrams step by step. Okay, but one important point to remember is that decide the diagram depending on your problem context, or what is because it's more about how you can easily show to the developer the roadmap of execution. If you make diagrams which are pretty complicated, probably the developer will not understand it, and then probably we lose the importance, or we lose the basic need why we need UML. I mean to say, if the UML cannot show a technical roadmap or if it is very difficult to understand for a developer, then definitely you should not use that diagram at that place, or probably use some kind of simple block diagrams to represent your technical documentation. So I conclude this video, and as I said, UML is nothing but it's all about a blueprint of your software code. I hope you have understood this video, and I hope that in the next coming slides we will try to understand all the 9 diagrams for UML.